Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Hope that you will be safe and healthy. Today our topic is law of mass action. This law was proposed by Goldberg and Waugh in 1869. Statement of law of mass action. This law states that the rate at which a substance reacts is directly proportional to its active mass, and the rate of the reaction is directly proportional to the product of the active masses of the reacting substances. The rate at which a substance reacts is directly proportional to the active mass of the reacting substances. Active mass means the molar concentration of the reacting substances. And the rate of the reaction is directly proportional to the product of the active masses of the reacting substances. Active mass means molar concentration. Units: mole per decimeter cube. And active mass can be represented by square brackets. Consider a reversible reaction. A reversible reaction, those reaction which proceeds both in forward as well as in reverse directions. So, A react with B and produced C and D products. When A and B reacts, so this is forward reactions. So the rate of the forward reaction is directly proportional to the active masses, to the product of the active masses of the reactants A and B. And when C and D reacts, they will produce A and B. So this is a reverse reaction. So the rate of the reverse reaction is directly proportional to the product of the active masses of C and D. Where K proportionality constant for forward reaction and Kr the proportionality constant for reverse reaction. Let A, B, C and D are the molar concentration of A, B, C and D respectively. When we take A in the square brackets, now it indicates the molar concentration of A. B indicate the molar concentration of B, and this C indicate the molar concentration of C, and D indicate the molar concentration of D. So, according to the law of mass action, rate of forward reaction is directly proportional to the product of the active masses of A and B. So RF rate of forward reaction is equal to Kf into A into B. What is Kf? The proportionality constant for forward reaction. Proportionality constant for forward reaction. Similarly, rate of reverse reaction, RR, is directly proportional to the product of the active masses of C and D. So RR is equal to Kr into C and to D. What is Kr? Kr is proportionality constant for reverse reactions. So at equilibrium state, the rate of forward reaction is equal to the rate of reverse reactions. We discussed in the previous lecture equilibrium state. if the rate of forward reaction become equal to the rate of reverse reaction, so this state is called equilibrium state. So rate of forward reaction can be represented by RF, rate of forward reaction. Rate of reverse reaction can be represented by RR. This is equation third. Equation first, second, third. R. Put equation first and equation second in equation third. Here RF is equal to KF into A into B. KF into A into B. So put KF into A into B instead of RF. So KF into A into B. RR, we know RR is equal to KR into C into D. So put KR into C into D in the place of RR. So KF into A into B is equal to KR into C into D. Or KF, divide both sides by KR. So KF over KR, and also divide both sides by A and B. So KF over KR is equal to C into D divided by A into B. We know that KC is equal to KF into KR. What is KC? KC is equilibrium constant. And KC from this equation can be defined as the ratio of the proportionality constant for forward reaction to the proportionality constant for reverse reaction is known as equilibrium constant, which can be represented by Kc. So, put equation 5 in equation 4th. We will place Kc instead of Kf over Kr. So, Kc is equal to C into D over A into B. This is the expression for equilibrium constant, which indicate the rate of the reaction depends upon the active masses of the reacting substances. Here, Kc can also be defined as the ratio of the product of the molar concentration of products to the products of the molar concentration of reactants is known as equilibrium constant Kc. So Kc depends upon the molar concentration or active masses of the reacting substances. So here if the reaction is in forward direction, so the rate of forward reaction is directly proportional to the product of the active masses of the reactants. And for reverse reaction, the rate of reverse reaction is directly proportional to the product of the active masses of the products. So this is the expression for equilibrium constant Kc, and this is the law of mass action. If you have any question, so please write in the comments. Hope, wish you best of luck.